Alright, this problem, do something very similar to what we did on Friday. You're just going to set that parentheses equal to your favorite variable. I'll choose alpha. So essentially you have tangent of alpha. You just basically need to evaluate tangent of alpha. Well, you do know some information. It tells you alpha is equal to the inverse of sine of x. Class, what does the inverse tell you to do? So let's switch these. I have x equals sine of alpha. Well, that doesn't really tell me much, right? I told you that you can make this a fraction how? Sine is positive in which two quadrants? Quadrants 1 and 2. Okay, we're going to draw a triangle in quadrants 1 and 2. What's the easiest quadrant to pick? Okay, let's do that so far. We're trying to solve for alpha, where the angle is alpha. Class, what do you know about sine? Yeah, just think back to Friday's lesson, opposite of the hypotenuse or y over r. So let's go ahead and put those on our right triangle. My opposite side of the angle is x. Opposite. My hypotenuse is equal to 1. I just need to solve for the adjacent. Class, how did we solve for a missing side of a right triangle given two sides? What do we use on Friday? Let's use the Pythagorean theorem. C squared equals a squared plus b squared. The most important letter here is C, which is which value? Does it matter what this is? B, call this one A. So now I'm just going to do my substitutions. 1 squared equals a squared plus x squared. So I have 1 equals a squared plus x squared. Class, what variable are we trying to solve? We're trying to solve the triangle, which is we need a, so we're trying to solve for a here. So I'm going to subtract x squared. I'm left with 1 minus x squared equals a squared. To get rid of the exponent, I have to. Let's take the square root. Remember that you're taking a square root of an equation, but you have, which gives you two solutions. I'm just going to switch sides. But remember, this is a distance of a triangle, so only pick the positive. A is equal to the square root of 1 minus x squared. Now, your temptation might be to try to simplify the square root of x squared. But this is an expression. You can't break it apart. Okay? So we just found, given alpha equals the inverse of sine of x, we found that sine can be in quadrants 1 and 2. We basically made this a fraction. We did the Pythagorean theorem. Now I have the three sides. But class, we're only trying to solve for which trig function? Tangent. Tangent which two sides? Tangent is opposite over the hypotenuse.
Wait, what? Opposite over.
Good job, you're paying attention. Tangent is opposite over the adjacent. I thought I had. Sometimes when I hear things, I don't know why. So the opposite side is how much? And the adjacent?
Arc 1 minus x squared.
Oh no! I got a radical in the denominator. What do you do?
Multiply that as a number.
Yeah. Just multiply by that. See this? Take all of it, multiply by it. So in the numerator, you're going to have x times 1 minus x squared. You're not going to do any distributing there or anything like that. And then denominator, you actually have 2 of these, don't you? And these will cancel, and you're going to be left with tangent of alpha equals x times square root of 1 minus x squared all over 1 minus x squared. So, to review the problem, you're still doing the same thing. You're still taking the inverse, gives you a clue. Draw a triangle, quadrants 1 or 2, and it's just a little bit more heavier on the algebra.